Okay, so we're looking at relations and their inverses, and an inverse is found by interchanging x and y values. So we start with something simple, just 3 points, and these are 1, 2, 1, 3, and 2, 5. Now the inverse is just the curly braces. Let's make the font a little bit bigger. And you swap the x and y values. So 1, 2 becomes 2, 1. And then the next one becomes 3, 1. And the next one becomes 5, 2. So just a little thing about notation. Make sure that you have two numbers separated by a comma within the bracket, that's 1 point, and that you separate each of these points with commas as well. Note that when you have the inverses, the domain and range will interchange. So in the original function, or the relation, sorry, the domain was x equals 1 and 2, and the range was y equals 2, 3, and 5. And in the new, or the inverse relation, the domain is now 2, 3, and 5, and the range is 1 and 2. Whoops, I can't, alright, scrub that off, that's 1 and 2 there. So here are some pointers about the graphs. The graph of an inverse is the reflection of the original about the line y equals x. So if I have a graph like this, with the axes there, the original would be a reflection of the inverse. Let's go that way. And so this line here would be the line of symmetry. So the reflection would be crossing through here, and it would look something, oh, I didn't want to do that, something like that. I was hoping to do a highlighter thing, but that'll do. Okay, other things. The x-intercepts become y-intercepts. So here we had an x-intercept and it's become a y-intercept, and vice versa. Graphs, if they intersect, will intersect on this line here, so that's where they cross over. Vertical asymptotes, we don't have any here, but if I had a vertical asymptote this way, then the inverse would have a horizontal asymptote, and vice versa. And the line from a point to its inverse will cut the line y equals x at right angles. So if I was to join this point with this point, and they are inverse points, then that would be a straight line, and it would cross at 90 degrees. And for best results, use the same scale for both axes. What that means is, if you're going 1, 2, 3, then you've got to make sure it's 1, 2, 3 on the other axis. So here's an example. Find the inverse of this blue graph, sketching both the original and the inverse on the same axes. Right, so the first thing I do is make sure I add the point that I should have put in there, which is 3, 1, that's the original point. And I reach for my ruler, and I'll draw that in with a red line. And the ruler has to be on the y equals x line, so it's going to go through there, like so. So wish me luck. That sounds good. Okay, so that's the y equals x line. Got a bit wonky at the end, but that's okay. So I take this point 3, 1 here, and I'll turn it into 1, 3. That's one good point to put in. So 1, 3 up here. Now the other thing I look for is where the original blue curve intersects with the red one, and it does right there, so that's going to be the point that's on the black curve, which is the inverse. So that's 0, 0. Okay. Now then I do my reflection trick. So this is the line of reflection, which means the shape is going to be something like that. And again, I'll draw it in black and take it gently. Something like this. Okay, now the purists among you would like to measure the distance from the line to each point. The main thing I'm looking for is whether you get the points and label them correctly, and similarly here I need to put in 0, 0. Done. Okay, here's one where you have the line y equals 3, and you can basically turn that into x equals 3. Now if you're not convinced, you can take a point along here, let's say that's 1, 3, and you can take another point that would be 1, 2, 3, 4, 5, 6, 3. And if we draw in the red line, which is y equals x once again, along here, something like that, you should find that it is actually x equals 3. Okay, so the intersection point is 3, 3. And if you were to take the original blue dot 1, 3 and make it 3, 1, then you get this point here, 3, 1. And then the other blue dot, 6, 3, would give you 3, 6, which is 1, 2, 3, 1, 2, 3, 1, 2, 3 up there. And indeed, if you join the dots with a ruler, you would actually get the x equals, whoops, I missed. Well, you get the idea, x equals 3. Okay, so lucky last one is a relation with 3 dots, or 3 points, just like we started. So this point is 1, 2, this point is 2, 4, and this point is 3, 1. So to get the inverse, you have to swap the x and the y values. So you get 2, 1, and 4, 2, and 1, 3. Again, use the curly braces. So 2, 1 would be over here. 4, 2 would be there. And 1, 3 is over here. Which doesn't make a lot of sense unless you actually draw in the y equals x line with your trusty ruler. Like so. So hopefully you can see a little bit better now that the reflection is indeed true, where these guys are reflections of each other.